Okay, once again, afternoon, folks. This time around, it's simultaneous equations for Form 2 syllabus. Hope you guys will find this interesting. So let's have a look at the information to be covered. Right, here we are with the points to be addressed. Let's have a look and check. Methods that we might use to solve this type of equations can be elimination or substitution. Sometimes we're given word problems, so we have to formulate equations. And normally these equations, they've got two unknowns, x and y, and we have to find either. So when we close our session, I think one should be able to solve simultaneous linear equations by using either elimination or substitution method, or if you're given a word scenario or word problem, try and convert that into algebraic expression, which actually falls to be an equation that you can solve using either of the methods given. So when we are solving linear equations, say we are using elimination, we arrange equations in standard form. When we say so, in other words, we are saying a certain variable x will be equal to, or y equal to, that's elimination. So the one that you make the subject is the one you eliminate. Then you make coefficients of one variable equal, add or subtract equations to eliminate a variable. We solve the remaining and substitute back to the second variable. So method two is substitution. When we make one variable the subject in one equation, substituting the expression, then solve for the single variable. Substitute back to find the second variable. Check our answer. So all this will look at it in detail as we solve the problems. Here are a bit of examples. You don't worry about them. Let's how we can follow what was required. So looking at this equation, we are interested in elimination. So things are in line, both x and y. So if you can see clear, if we add in line, we are going to get x plus x, that's 2x, plus y minus y, we eliminate y, then 12 plus 4 gives us 16. Therefore, we have got an equation 2x equal to 16. Therefore, our x is equal to 8. Then I pick any of these two equations. Now, the first one is nice, which says x plus y is equal to 12. I put my x as 8, so it's 8 plus y equal to 12. When I transpose this, end up having y equal to 12 minus 8. Therefore, my y is actually 4. So I now have two values for x and for y. We try and test on this equation that if I arrange in linear manner like we did, because we want to test if we can eliminate. Well, this time around on the y, the signs are not the same. So it's wise for us to, instead of adding, we actually subtract the corresponding variables. Therefore, when we subtract is 3x minus x, it gives us 2x. When I say y minus y is eliminated. Then 14 minus 10 gives me 4. I now have an equation where if I divide both sides by 2, my x is actually 2. Then, as usual, we can try with the first one. Say, we are saying 3x plus y is equal to 14, but I know the value of x is 2, so it's 3 times 2 plus y equal to 14. But this simplifies to 6 plus y equal to 14. When I transpose, I have 14 minus 6. Therefore, my y is actually 8. Done with that, we move to the third problem where we are using elimination. It's no substitution. So again, in linear fashion, we try and compare. On the y, we can see that we've got the same item. So we can subtract to eliminate it. So if I say 2x minus 4x, I get minus 2x minus y minus y becomes minus y plus y, so y is eliminated. Then 7 minus 11 gives us negative 4. I'm interested in the value of y, so I'll divide both sides by negative 2. Here it cancels, therefore, my x is actually 2. Then I'll pick the first equation here, or any, but I think the first equally suffices. Then, because my x is known as 2, so 2 times 2 minus y, it gives us 7. And when I simplify here, I get 4 minus y equal to 7. Therefore, my y is actually 4 minus 7. So y is actually negative 3. Still moving. Here I need to first rearrange because my things are not in proper form, especially the first part. I might be interested in rearranging it so that I have all components in order. So when I do so, I'll end up having minus x plus y equal to 3. Then looking at my scenario here, I think if I do it in line again or in linear format, Looks like at y, I've got common items, so it'll be wise for me to subtract. So if I subtract corresponding 3x minus x, it gives me 4x. Y minus y goes away, equal to 15 minus 3, it gives me 12. When I divide both sides by 4, actually my x is 3. Then I pick the first equation here, which is saying y equal to x plus 3, but the value of x is known. It's actually 3 plus 3, therefore my y is 6. So I've got my two values, one for x, one for y. I'm moving to number 5, where at least here, things are in order, because if I look linearly, things are in order. So I can subtract to eliminate here where things are common. So when I do so, 5x minus x, it gives me 4x. 2y minus 2y gives me 0. So 16 minus 8, I get 8. So when I divide both sides by 4, and this cancels, my x is actually 2. When I come this side, because I've got my x now, 5x plus 2y equal to 16. Therefore, 5 times 2 plus 2y is equal to 16. This simplifies to 10 plus 2y equal to 16. Therefore, 2y is equal to 16 minus 10 when I transpose. So 2y is actually equal to 6. When I divide both sides by 2, it tells me my y is actually 3. So I've got both x value and y value. Let me take a slight break, then we'll proceed with number 6. Thank you.